Welcome to EDU World Space.
To answer this question, we must first go over what is given. So we know the charge of the proton, the mass of the proton, and the separation between the protons. So to answer part A, the electron is located at the midway point between the two protons. So the distance of the electron and the proton is equal to 5.35 times 10 to the negative 11 meters. So the potential energy between the electron and the proton is equal to 2 times 1 over 4 times the permittivity of free space times pi, and this is just Coulomb's constant times the first charge over the times second charge over the radius of separation. So now, if we compute this with the things that we were given that I stated just before, so we're going to get that since this is just a constant, this is 8.99 times 10 to the power of 9 times 1.6 times 10 to the negative 19. And since it's 2 electrons, all we need to do is square it. And as I said before, the radius of separation is equal to 5 point. So this is the midway point from the radius that we're given. So it's 5.35 times 10 to the negative 11 meters. So now if you compute this into our calculator, we're going to get that the potential is equal to negative 8.6 times 10 to the negative 18. And this is joules. So now that's the answer to part A. So now moving on to part B. So let's say the electron is moving along the perpendicular bisector of the line, joining the two protons, and its initial velocity is equal to v is equal to 1.5 times 10 to the power of 6 meters per second. This is given. And the final velocity is 0 at the distance of x from the center of the line joining the two protons. So once again, the potential at this distance is equal to u, and it's the same equation as here. So now if we just did this, instead of writing that again, let me just go ahead and just write down the values, straight to the values. So it's 8.99 times 10 to the power of 9 times, again, since it's two protons, it's 1.6 times 10 to the power negative 19. But this time, as I mentioned before, the radius is equal to the square root of r squared plus the distance x squared. And now this whole thing is multiplied by 2. So now if we solve for this, if we simplify it, we're gonna get that 46. So let's just simplify the top. 46.13 times 10 to the negative 29 is equal over r squared plus x squared. So now, and remember this is in joules since this is potential. Let me write potential prime so we know that, so we can differentiate between the two potentials and the two parts of the equation. So we know that the kinetic energy of the electron, let's do that over here in blue. So we know that the kinetic energy is equal to 1/2 mv squared, and we know all these constants. So if you just plug it in, it's going to be 1/2 times the mass of the proton, 1.1 mass of the electron, which is 1.09 times 10 to the power negative 31. And remember, this is in kg, so standard units. And then 1.5 times 10 to the power 6, and that's the speed of the electron. Now, if you compute this, we're going to get that the kinetic energy is equal to 1.025 times 10 to the negative 18 joules. So now, from the law of conservation of energy, we know that the initial potential plus the final kinetic energy is equal to the final potential, since at the end there is no speed of the electron, so the kinetic energy is equal to 0. So now if you plug in all the values that we got from both part A and part B, so far, we're going to get that negative 8.6 times 10 to the negative 18 joules plus, so that's the initial potential, plus the initial kinetic, which is equal to 1.025, which you just calculated, times 10 to the negative 18, is equal to this. So let me just bring this down here. Now all we need to do is isolate for the bottom part here to solve for these variables. So if you do a little bit of algebra, we're going to get that the square root of r squared, and we might as well simplify the equation too. So just add everything and then divide by this, divide by the numerator of the right side, which is equal to 6.075 times 10 to the negative 11. So now if you solve for x, since you know the radius, so x is equal to the square root, since x is squared, let's just do the algebra in one step to make it quick. So it's 6.075 times 10 to the negative 11 minus the radius, which was 5.35 times 10 to the negative 11. And this whole thing is squared, since the radius is squared up here in this previous step. And if we compute this, we're going to get that x is equal to 2.88 times 10 to the power of negative 11 meters. And that's it for this question. Thank you for listening.